Hey guys, welcome back to the channel. In today's video, we're going to be going over using calculus to determine the maximum and the minimum of a function. By the end of this video, you'll understand what a maximum and a minimum of a function is. You'll understand how to use calculus to find out where that maximum or minimum lie, and also have a strategy to determine the local and the absolute maximums and minimums of a function. If you guys get some value out of this video, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. Alright, let's get started. Okay, before we start talking about calculus and how to find the maximum and minimums, let's figure out what that actually means. So for all these functions here, I'll do it in purple, what we're going to have is a maximum value, so this red parabola, since the largest value you can get to is at its vertex, because it's downward sloping, or downward opening, that would be the maximum right here. Then for this cubic function, it could be cubic, but it's definitely an odd function, this will be a max, and down below will be a minimum. And if we had a harmonic or periodic function, we'd have multiple maxes. They'd all be the same value. They would just occur at varying x values. And then below, would be the minimums. So that is what a max and a min is. People also talk about turning points and things like that. And we're going to use calculus soon enough to figure out inflection points and those kind of things. And it's very important for curve sketching. But what I want you to get across, or what I want to get across in this video, is that the slope at a maximum or minimum value is always 0. So if we took the derivative at that value, the slope would be 0. And you could see this by, if I drew a horizontal line, well, slope is defined as rise over run. So in this case, in this orange line, there's no rise. So that means it's 0. So then therefore the slope at that point will be 0. The same with the minimum. So I could do another maximum slope there and a minimum slope there. The slope at a maximum or minimum will always be 0 because it's a horizontal line at that point. So it's really important to understand that, and then when we use our knowledge of calculus and realize that derivatives are just slopes, what we can do is now find the maximum minimum of any function by getting the derivative of that function and then setting it to 0, because wherever it's 0 will be a maximum or a minimum. So here we have like our first example problem, and I think it's really easy to explain this if we just talk about an example problem first. So what we're first going to do is take the derivative of this f of x function. So in this case, this is going to be negative 6x squared plus 18x, and then that constant 4 is just 0, becomes 0 for the derivative. So now we have the derivative. We have the slope of this function at varying x points. And we know that the maximum or minimum of a function will occur when the slope is 0 or the derivative is 0. So I'm just going to set this to be 0. And then say 0 is equal to negative 6x squared plus 18x. At this point, you should realize that this is a quadratic, and we can factor this to solve for our x values. So what we can do is we can say 0, and I'm going to factor out I'll factor out a negative 6x. So, and then inside here, this will be x, and then it'll be minus 3. So now, what we realize is that a maximum or a minimum will occur at x is equal to 0. So that's this part of the solution. And also at x is equal to 3. And that would be this part of the solution. So now we don't know whether it's a max or a min, but we know that they occur at 0 and 3. So the first step in our strategy, the first step would be take derivative. And then the second step would be to set that derivative to be 0. Because again, that's when the slope is equal to 0. So set derivative to 0. What we need to do now, though, is determine whether it's a maximum or a minimum. And the way we do that is using the derivative to help us understand what the slope is doing up to that point. So if we had a function where, I'm just going to make it up on the spot, but say we had a function that looks like this. What we have here is we've found the locations, and it's not corresponding to this graph, but we found the locations where the slope is 0. But we need to know and use kind of algebra and calculus to figure out whether or not it's a maximum or minimum. And I want you to notice that here, this is a positive slope, right? It's increasing. And then it goes into a negative slope. So if we go from a positive slope to a negative slope, that results in a maximum. And hopefully you can kind of see that as we go up to this point, the slope is increasing, so it's a positive slope, and then it goes to a decreasing slope. And of course, that creates our maximum value there. And similarly, if we look at what a minimum does, well, it's going as a negative slope, and then it goes towards a positive slope. So that would be a minimum, is when we go from negative to positive. That leads to a minimum. So that's all well and good when we have a graph to look at, but to find out what this would be algebraically, we need to plug in some points. So what I'm going to do is I'm going to plug into our derivative function. So the one up here that we found, that is our derivative. And I'm going to use this function and plug in some test points both before our maximum minimum and after. So I'm going to plug in f prime at -1. So this is going to be -6 multiplied by -1 squared plus 18 multiplied by -1. So this ends up being -1 is equal to, so this is going to be 1, so this is going to be -6, and then this will be -18. So we get a slope at a value before our maximum point. This is going to be -24. This is a negative slope, so we're going this way before our maximum or minimum. Now if I try a slope after our maximum or minimum point, so let's do f of 1. So this is going to be, well, we'll have -6 multiplied by 1 squared plus 18 times 1. So here we're going to get a value, let's see, this would be -6 plus 18. So our value after our maximum or minimum value would result in a positive slope. So now we know that at x is equal to 0, the function is decreasing before as a negative slope, and then it's increasing after. So if we kind of fill in the blank here, that ends up being a minimum. So we can now say, using algebra and calculus, that this here is a minimum. Now I'm going to use the same strategy for our other point, our x equal to 3. So now I'm going to say f prime of x, and I'm going to do it at 2, because that's right before 3. So this is going to be equal to -6 times 2 squared plus 18 times 2. So we get a slope at a value of x is equal to 2. Well, that's going to be 4 times -6, that's going to be -24 plus 36. So at 2, the slope is a positive 12. Now if we look at the slope after our max point or min point at 3, this would be at a value of 4. So this is going to be -6 multiplied by 4 squared plus 18 multiplied by 4. This will end up being -96 plus 18 times 4, that is 72. So we're going to get a negative value here. And that'll be -96 plus 72 is -24. So now we're going from a positive slope this way, so this is positive, and then we're going to hit something and go into a negative slope. So this is clearly a maximum. So now we know that this value at x is equal to 3 is a maximum, and we've solved our problem. So now if we look at our strategy, we're going to add a step. And this step will be plug in test points before and after the max/min values of our derivative function. So that would be the third step, is when we're checking whether it's a max or a min. We know it's either one, but we need to now check if it's a maximum value or a minimum value. So going through some more example problems, we have example problem A, and this is going to be determine the absolute extrema, or extreme, of each function on the given interval. So here we're going to do the exact same thing. We're going to find the maximum and minimum. And the only thing we need to note about this is now we have a boundary. So now we have to evaluate the slope, or I guess the value of it, at 0 and 3. Because if we look at this function, it's bounded at these points. So right here we have at x is equal to 0, it is at a value of 3. And then over here we have at a value of 3, its y value is 0. So we have to evaluate it on the endpoints of the function, and then also find, this will clearly, by looking at this graph, we can see that this is the minimum point, and then the maximum point would be up here because that's where the function ends. So obviously that would be the max. So now we're going to have to add another step into our strategy where we evaluate the endpoints. So in our strategy, I'm going to say evaluate endpoints of the function. Okay, so back to the problem. And again, we're going to use calculus because, again, if we had a graph, it would be easy, but sometimes we don't. So what we can do now is take the derivative of this function. This will be 2x minus 4. We now set this derivative to 0, so that is now our second step. And if we solve this, well, this is going to be, I'm going to factor out a 2. This is going to be x minus 2. And at a value of x is equal to 2, we get a maximum or a minimum. So here, if we check on our graph, we can obviously see that that is a minimum. But again, I'm going to use our algebra and our calculus to solve that if I didn't have the graph. So now I'm going to say f prime of, let's call it 1, because it's right before 2. So we're going to say 2 times 1 minus 4. So that would be 1, this is going to be 2 minus, so it's going to be negative 2. So it's a negative slope, and that makes sense because in this graph it is decreasing that way. Now we're going to apply a point after the maximum value. So let's do f of 3. So this is going to be 2 times 3 minus 4. And that would be 6 minus 4, that's going to be 2. So now it's a positive slope, so now we're going up. So if we go down and then we go up, so a negative slope to a positive slope, this would have to be a minimum value. So now we know this here is a minimum. And lastly, we're going to evaluate the points or the function at the endpoints because that's where it's bounded. So if we looked at this function, clearly there is no maximum point that's traditional where the slope would be 0 like that, but we have an endpoint, so we definitely have a maximum. So what we could say is that the value of the function at 0 is going to be 0 squared minus 4 times 0 plus 3. So here, our max value would be a value of 3. So this would be our max. And then we would check to see if the endpoint would give us a minimum value. And I think if you could see in this graph, if I scroll up a little bit, here, this is definitely not lower in value than our actual minimum. So we know for a fact that it's going to be not the case that this endpoint actually shows a minimum or maximum. But let's just do it anyways to kind of prove this point. So here this will be f of 3, and that's going to equal 3 squared minus 4 times 3 plus 3. So this value would give us 9 minus, that's going to be 12 plus 3. So 9 minus 12 plus 3, this gives us a value of 0. So here, this is clearly not lower than our value we would have got at our minimum point. So now we're going to plug in what our minimum value would be, because when you plug in that x is equal to 2, using calculus, that's where we found that slope to be 0. So lastly, we're going to do f of 2, and this is going to be 2 squared minus 4 times 2 plus 3. So f2 is equal to 4 minus, and this is going to be 8 plus 3. F of 2 is going to be, well, it's going to be negative 4 plus 3. It's going to be negative 1. So that value here is clearly our minimum because it's lower than our endpoints. Our endpoints had a max, but they didn't have a min. And that would be problem number A. All right, so now we're looking at problem B. So here we're going to apply the same strategy. And the strategy again goes, we take the derivative, set it to 0, find the value at that point, and then also find out whether it's a max min by using derivative test points. And finally, check the endpoints of the graph, because if our graph is bounded, then clearly it might have a maximum minimum at those bounds where the slope is not actually 0. So here we're going to take the derivative of this function, and it's going to be 3x squared minus 6x. And now set it to 0. This is 3x squared minus 6x. This is a quadratic, so now I can factor this out. So this is going to be, I'll factor out a 3x, and this will be x minus 2. And then now I know I have a point, a maximum point at, or minimum point at x is equal to 0 and at x is equal to 2. So we now need to test those points to see whether it's a max or a min. So let's do f prime of negative 1. So this is going to be 3 times negative 1 squared minus 6 times negative 1. And here we will get a value. So here we'll get a value of 9. And so that's a positive slope, so it's going upwards like this. Now I'm going to do a derivative or a value of our derivative function at just after 0, so at 1. This is going to be, let's see, this will be 3 minus 6. So now we're going to have a negative slope. So we're going from negative or positive to negative. This clearly is a maximum value or potential maximum value because it could be larger at the extremes or where it's bounded. So now we know it's going to be a max, a potential max, right? So here, if we plug in a value of f of 0, we're just going to get a value of 0. So the function doesn't go higher than 0 in this case, or at this point. So I should have mentioned this previously, but right here, we have x belongs, the function's only bounded between -2 and 1. So we actually don't even need to evaluate this one because it's x is equal to 2. So the function doesn't exist actually there. So we actually don't need to evaluate that. But what we do need to do is evaluate the function at -2 and 1 to see if we get a minimum value there. So why don't we do at -2, because that's where it's bounded. So this is going to be -8 minus, and this will be 12, and that would be the final answer. So this would be -2, and this would be -20. So that's one potential minimum value. And then if we put in the value of 1 to see what we get, well, we're going to get, it's going to be, 1 cubed, so it's going to be 1 minus 3. So f of 1 is equal to -2. So clearly this is our minimum value. So it is evaluated at our endpoint, so this is minimum. And over here, this would be our maximum value, because that's sort of the derivative, or the slope of the line was actually equal to 0. All right, so now we're moving on to a word problem. And I think in these word problems, you'll start to see, the rationale of why we're learning this, because it can have some pretty important implications. So this word problem states the concentration C of T in milligrams per cubic centimeter of a certain medicine in a patient's bloodstream is given by the function C of T is equal to 0.1 T over T plus 3 squared, where T is the number of hours after the medicine is taken, and they're asking us to determine the maximum and minimum concentrations between the first and the 6th hours after the medicine is taken. So again, when we see maximum and minimum, I want you to think derivative to 0, because the maximum is going to be when the slope at that point is 0, or the derivative is 0. So whenever you see maximum minimum, think derivative to 0. We also have this function that's bounded by 1 to 6. So we only care about this function. It only applies in this 1 to 6 hour range. So we're going to need to take the values at 1 and 6 to see if those endpoints are in fact lower or higher than the maximum we find, or minimum we find. So we're first going to take the derivative of this, so c prime of t. And if we look at this derivative, or this function, this is going to require the quotient rule. And I'm going to talk about the top part being f and the bottom part being g. So now if I do f prime, that will be 0.1, because the function was 0.1 t. And then g prime, this would be 2 times t plus 3. And then we're doing the chain rule here, so we're taking the derivative of this inside. But the derivative of this inside is just 1, so g prime is really just 2 times t plus 3. And now we can apply the quotient rule. So here we're going to have f prime g, so the quotient rule, remember, is f prime g minus g prime f over g squared. So that's what we're going to do here. So we're going to do f prime, so that's 0.1, multiplied by g, which is t plus 3 squared, minus, and then it's going to be g prime, which is 2 times t plus 3, multiplied by f, 0.1 t. And that is all over g squared. So t plus 3 squared, and then all of that squared. So what I'm going to do now is I'm going to factor out a t plus 3, because there's a t plus 3 in each of these terms in this equation. So I'm going to say t plus 3, and I'm going to factor it out. So up top we're going to have 0.1 multiplied by t plus 3, and then minus 2 times 0.1 t, because we factored out that t plus 3. In the bottom, I'm going to also factor out a t plus 3, just to show you that it cancels. So this is going to be t plus 3 multiplied by t plus 3 to the power of 3. And now that you see that, I think you can realize that we can cancel this t plus 3 on the top and the bottom. Once we've done that, we can also set this to be 0. So I'm just going to erase this part and just say, okay, this is actually 0 because we're trying to find the maximum and minimum values. So here, if I were to multiply t plus 3 cubed by both sides of this equation, what's going to happen is, well, this bottom term will cancel, and then t plus 3 to the power of 3 multiplied by 0, well, that's just going to be 0. So that will make our function a lot easier to deal with. So here we have t plus 3 minus, and then it's just going to be 0.2 t. And now we have our function that's a lot more simplified. So here we're just going to now solve this and be 0.1 t, or I guess expand it, plus 0.3 minus 0.2t. And if we collect like terms, this will be negative 0.1t plus 0.3. If we solve for t, we're going to get a value of 3. So at 3, we either have a maximum or a minimum, right? Because the slope is definitely 0 at that value. So what we're going to do is we're going to plug in, we're going to look at the derivative function. So we can look at kind of any of them. Let's look at, I guess I'll rewrite it to make it more clear. So here we have our derivative function, and I'm going to plug in test points that are both before and after this maximum or minimum. So here I'm going to apply the slope at 2. So this is going to be negative 0.1 times 2 plus 3 over 2 plus 3 to the power of 3. So this is going to be at 2. And so this here would be negative 0.1 times 2 plus 3 divided by 5 to the power of 3. So we're going to get a positive 0.0224. And that is a positive slope there. The value doesn't really matter. We just need to know whether it's positive or negative. So we could probably see that it'll be positive based on just this numerator here, because the denominator is not, affecting the positive or negative. But it's always good to just be thorough and check. The next point we're going to check, C prime, is going to be 4. So here this is going to be negative 0.1 times 4 plus 0.3 divided by 4 plus 3 to the power of 3. So again, we're trying to see if this is positive or negative. So negative 0.1 times 4 plus 0.3 divided by, well, that's going to be 7 to the power of 3. So I now get negative 0.0002915. So now this slope is negative. So it went from a positive or an increasing slope to a negative. So this clearly has to be a maximum that it is approaching. So now we know that at 3 hours, we have a maximum concentration of this medicine in our patient's bloodstream. So the last part of this problem is we need to check the endpoints. So here we're going to check the value of 1. So this is 0.1 multiplied by 1, and then it'll be 4 squared. So C at 1, this will be 0.1 divided by 4 to the power of 2. 0.00625. And then we're going to have C at, let's say, 6. And let's see what we get there. Point, so it's going to be 0.1 times 6 divided by 9 squared. So C at 6 is going to equal 0.1 times 6 divided by 81. So this is 0.007407. So clearly this value is smaller than the other value. And we already found the maximum, and that was at time is equal to 3. So here we have a minimum value at this endpoint. So that would be the minimum concentration. It kind of makes sense because we're administering this medicine and it's not yet in the patient's bloodstream. And lastly, what we need to do is plug in to the function C of 3, where the function hit a maximum value, right? Because we know where it happened, but we want to know what that amount would be. So if we look at this function again, this is going to be 0.1 times 3, and then it's going to be 6 squared. And this value will be 0.1 times 3 divided by 36. We get 0.00833. So here, this 0.00833 is our maximum concentration. So we have a max and we have a min, and that would be the answer to that question. Thanks for taking the time to watch this video. I really hope you guys got some value out of it. If you did, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. If you have any suggestions on what you want me to do next, let me know down in the comments below. Thanks again, and I'll see you guys in the next video.